As you heard, I've been around the world and I've been to a lot of different places, and I've had the opportunity and the luxury and the privilege to speak in many, many different places. And I have to say, it's a little bit strange being here in front of you. This is my alma mater. I did my undergraduate degree here. I've taught many of you, and I'm colleagues with many of you. So I was explaining to Doug Noble earlier, it's a little bit like performing in front of your parents. You know, normally you go to a place and it's a bunch of anonymous faces and you can just kind of talk and, you know, you're like, yeah, I can convince them I'm smart. Here you're like, oh man, they actually know me. Anyways, so as a sort of tenure track lecturer here, a faculty lecturer, it's been an opportunity for me to really kind of be reflective about my work for this opportunity. And so I think what I'm going to talk about has a bit of a framework that is both figurative and literal in terms of thinking about the moire effect. Are we going to kill the lights, or do I do that here?
You can push that button right here.
Where is it?
Is that the big dial thing here?
No, just the video.
Push video. You think I can see a video?
Right here. You see it?
Video.
Video.
Okay. So first of all, how many faculty does it take to turn off the lights? So the title of my talk, Coincidence, Incidence, Interference, deals with the moire effect. The moire effect is basically you take a pattern and you add an overlay, and the intersection of those patterns creates an emergent third pattern. That emergent third pattern is one that is defined by what I call coincidence or alignment, incidence or intersection, and what I'm most interested in is interference, multiplication, where the actual pattern itself is highly defined not only by the frequency of those two patterns and their relationship, but more importantly by the relationship of the viewer. So the viewer shifts that relationship as they move around. And the way I like to frame my work is it's the sort of interference between two strata, design practice and design research. Design research is looking at technology as a technique, as a sort of scientific strategy to discover innovations. And design practice is looking at technology as a tool, looking at practical automation and how it's used in practice. And the viewer in this case, or the project lens, is the project. Right? So through each project that I'm exploring, I'm looking at that sort of area here where they intersect and this kind of emergent pattern appears. And that's what I like to call exploratory practice or applied research. So the way I'm looking at this is always as a creative practice, as a designer, not as a scientist or a researcher. I'm a designer that is interested in research. I'm also a practitioner that is interested in research. But I'm most interested in the creative aspect of really trying to use this research to develop a new sort of design intuition. And the distinction between technique and tool is something I talk about a lot, inspired by Ali Rahim at University of Pennsylvania. And he talks about the invention of the single propeller fighter plane as a tool, and technique being learning how to fly and how to use that tool. And I'm talking about intuition as the kind of sensibility you derive from getting a feel for that tool and getting a feel for the techniques, and then your ability to maneuver within those two strata to guide yourself. So the name of my practice is called Synthesis. It's very much about the definition, which is about the combination of parts to complete a whole, but also about combining often diverse conceptions into a coherent whole. As Dean Ma mentioned, our work, though we're based here in Los Angeles, is spread around the world. Our consultants, which are a really key part to the way we work, are spread around the world. And our staff comes from around the world. So we like to think of LA as a place where we export ideas and import talent. When I first presented here at the USC School of Architecture 3 years ago, I came and I had one project to my name, which is this one. In those 3 years, been, to put it politely, busting my ass. And we've put together an extensive portfolio, which is growing by the day. Some of these are paid, some of them are not. It's a huge range in terms of scale. So it moves all the way up from very, very large mega projects, I like to say, down to a pair of eyeglasses, which we did with a company called Silhouette and Wallpaper Magazine. All of these projects are very different. Some of them are academic, some are self-initiated, some are the results of competitions, actually most of them, the results of competitions. A few we've won, one is still pending, so fingers crossed, we just submitted 2 days ago. Which has led to a number of commissioned projects. Those commissioned projects have enabled us to realize a few. All of them for us are research projects. So all of them are projects that through the lens of a design project or the constraints of a design project with very specific deliverables and very specific design constraints, we look at what we've kind of classified as 4 categories of research that we're looking at. One is digital craft. I like to make up terms, so digital craft is one of them. Performative patterning is another. Informed form is something else that we are talking about a lot. I'll talk about all of these later, so I'm just going to kind of introduce them right now. But the one that kind of ties everything together and is really the kind of universal strand that ties all of our work together is this idea about geometric logic. So first I'm going to talk about digital craft, and I'm going to break this into chapters, although all of the projects, as you saw, have different bits and pieces that overlaps of how they meet all of the different topics. But digital craft is really about thinking about craft in a new way, and thinking about craft as something that is not just about the handmade, but also becomes something that is about things that are made digitally, either through digital modeling, which there's a craft to the way you model, but also through digital fabrication and machine-based protocols for fabrication. I'm going to briefly go through this project because most of you have seen it from the first lecture I gave here. It's a pavilion which was constructed in London, England for the Architectural Association. It was a competition sponsored by Fiber C, which is a fiber-reinforced concrete manufacturer. The competition proposal we put together basically looked at one continuous form which housed all of the different programmatic requirements in one form. So it basically blended from all of these different sectional conditions and produced this shell-like structure, all to be manufactured from Fiber C, which is a fiber-reinforced concrete. So it's thin sheets of concrete with fiberglass filament mesh material, which basically makes it like a fiberglass or concrete plywood. Comes in 1.6 by 2.6 meter sheets with a 13 millimeter thickness. We proposed a sort of basic notch joint flexed into position, overlapping notches, a modeling process which was driven by a series of polylines which define curves. Those curves define a skin. The skin gets sectioned in both directions. Those sections get intersected to produce a series of intersections to identify where those notches fit together. At the time of the competition, we had 9,000 unique intersections. That number was rationalized to produce 2,000 intersections, and 2,000 intersections color-coded here for 7 different types. Each of those types allows for a delta of 15 degrees. Our structural engineers, AKT, developed a really innovative C# plugin, which was taking our Rhino node and point network and looking at the way that we intersected and looking at the way they intersected. They're only looking at how those eccentric beams intersect at the nodes and not how they overlap. And they're taking those nodes and basically sizing them off of those structural loads to give us a structural depth. And so you can see here it starts to do what basically Gothic arches do or Gothic vaults do. They widen towards the noses. And as you can see there, it's starting to get really, really thick and far, far deeper than what we were interested in, as you saw from our initial diagrams. So we're beginning to work with this geometry, rework it, and finally we got it down to a reasonable depth. We did have to include this little dark secret, which was the 3 steel continuous beams which we painted gray and pretended were concrete and didn't tell anyone about. Basically because once we got the structural load to work out and the depth of those beams kept getting thicker and thicker, or deeper and deeper, the lateral loads on the structure started getting bigger and bigger. So those beams were actually not about span or dead load. Those were entirely about live load, so lateral load, and wind pressure. So basically, with the amount of time we had a number of options. We chose to go with the fastest and most invisible one. Went to a process of producing an 80-page construction drawing set, which was inspired by IKEA. So basically a kind of flat pack assembly instruction for how to put together 800 unique pieces. Went to site with 800 pieces that were intersected in 3D space. The notches were identified, named, unrolled, and then sorted onto 2D sheets and nested. Sent and cut by water jets, reverse sequenced, and then flat packed into a big rig, brought out to site, assembled over a course of 8 weeks. It wasn't as seamless as the process as I just indicated, but I don't have time to get into the guts of it. But in the end, we were able to produce this more so with the help of this as our construction document than we were with that set of drawings. So we basically brought this 1:10 scale model to site and used it as a guide. Here's the pavilion on site in Bedford Square. It was a really big hit in terms of its presence in London. We originally had a 3-month building permit, extended to 6 and to 9, ended up being a year before they decided they could no longer extend it. It was unpacked, sold at an art auction by Phillips de Prury, the art house, sold to an art collector in in Singapore, who received all the pieces, all the drawings, the detailed digital model, and the physical model. And we've never heard from him again or seen a photograph, so I don't know what he did with it. But he did pay £175,000 for it, which I did not receive a cent of. So this is the pavilion on site with the perimeter gate around it on opening night, as is typical of architects. We finished construction at about 3 a.m. prior to the opening. What you don't see here is there's 2 steel props sitting inside of there, and myself and my partner, Alan Dempsey, who I did the project with, arguing about whether or not the structure would stand. Hanif was our structural engineer and gave a brilliant lecture here 2 years ago. If you guys got to see that, it was one of the best I've seen here. But basically arguing that the structure would not stand because it was not the structure that he had actually engineered because of all of the shifts and on-site revisions we had made. What we had to do was basically agree to leave the props in, open it for the opening, then close the gates, take the props out, and do a 3D scan for 1 week to see if there was any creep. Once we did the scan for 1 week, it was determined that it would stand without the props. We opened the gates up, but we did have to put up this stupid sign, which in the UK is enough to eliminate yourself from any liability. That would not work here. So this next project is one of the first projects we managed to land after we got started as a practice in, it was January 2011. It is a small home office interior for a private client in Chelsea, London. This video is actually put together by a former student of mine here at USC, Banaz Farahi, who is now in the School of Cinema. But you can see here, this is the client, Charles, in his home office. This home office is 7 square meters, so it's tiny. But he had a lot of stuff in there, and he's a financial guy, collects a lot of art. And in London, space is a big premium. So what he really wanted to do was try to have something that matched his art collection in terms of sculptural presence, but also was quite minimal in terms of disappearing and hiding all of his stuff. And also, we really wanted to kind of maximize the amount of space that was in here. And so he wanted something sculptural, but didn't have a lot of money. So we thought a lot about how can we do something sculptural without a lot of money. And so basically the strategy was to move towards thinking about creating two-dimensionality out of, or three-dimensionality out of 2 dimensions, and going towards this contouring strategy of kind of creating this skin and then contouring it with a series of flat sections, and then nesting a series of volumes inside those sections. So all of these sections are made out of birch plywood. It's a really beautiful laminated plywood, which can either be called it's called laminate ply, or here we call it a Euro ply. Over there they just call it ply. Nested all of those cuts into sheets, got about 75% material efficiency. You can see here how all the kind of volumes fit together into that space. Everything is pre-assembled into modules, assembled off-site. Other than the Z-clips, which are attached, everything is only fixed by gravity. So you're actually just bringing everything, hanging it, dropping it on. The stuff's really heavy, so it's not going anywhere. And that's the final project. One of the things that's really nice about this project is one, the edge finish in terms of how that Europly develops this really kind of amazing sheen through the laminates, but also this kind of moire pattern that appears. And, but also this moire effect of where you see between those slots. And because those slots are all only fixed at the back end where they sit on those channels, the front end, we needed these horizontal spacers to lock them together. And one of the key features here was the client is an avid traveler, so he wanted a world map on his wall, but similar to the installation, he wanted it but didn't want it present. So we basically were able to map the world map on here as a sort of graphic pattern, as a structural spacing pattern. Here's the layout and the nested volumes. This is actually a self-initiated project, which we're looking at the process that we're going through here, and well, how can we try to get zero waste? And we ended up not doing zero waste, and it's a table. But basically what we were trying to look at is nested volumes and how we could use this milling process to get as much material usage and embed the way it's being cut into the geometry, into the design of the geometry. So we set up this parametric model, which is basically defined by these 4 volumes or 5 volumes, and the spread of the legs, the angle of the legs, the offset, everything is controlled parametrically through a series of sliders, this angle of rotation, which then gets mapped out to a series of cut sheets. In this case, through the sliders, you can input how many sheets you're going to divide it into. We input how many sheets. It sets up the frequency of how you ordered all of these things. They get put together like this. You've got a tempered glass tabletop series. This is actually the outline of the 3rd cut, and then this is spacing off the top. They all get laminated and then assembled together like this. It got selected for the Beijing Biennale this past year, and then about 1 week before it got constructed, they could afford to build it for us. They couldn't afford to fly us over there and manage the process. About 1 week before it opened, they showed us the version of the table that they had produced, and we said, pull it. We don't want it included. They managed to mess it up pretty bad. Just put it that way. We're not happy with what it was, so I will show you the renderings, not the final product. The next topic is performative patterning. And so again, this is going to show up in just about every project we show, this idea of the moire and the idea of the pattern. What you see in the background here is a painting by Bridget Riley, and very much inspired by British op art, and art that is really about the moire effect, and kind of, in the case of these paintings, is about creating two-dimensionality or three-dimensionality out of flat surfaces. And we're really interested in how this kind of promotes visual interaction and how you really are engaged with space and surface conditions, and what we call responsive patterns, not in a literal sense of interactivity, but in terms of pattern being responsive to information that you're embedding into it. This is a facade which was done for a client in Lampang, Thailand. Lampang, Thailand is in the boonies. It's northern Thailand, just outside of Chiang Mai, mostly rural farmland. and this small little city in the outskirts. And this was interesting because it was a big client I had with another office I was in who came to me and said, we'll give you this project as a sort of trial. You know, it's not a big project for them. They just wanted us to do the facade just to see what we could do. So this is the project, this is the site, and it basically sits in front of a major freeway. And so your main impression of this thing, as many malls in Los Angeles, is driving past it. So what we were really interested in is how do we skin this thing in a way that promotes visual interaction through movement. So by taking, and they also didn't have a lot of money. So we began looking at the kind of regular grid, how we could create it as a diagrid where you get this kind of moire effect of passing by it, and then how you can modify that grid to be more freeform, and then rationalize it to be constructible. So we began looking at a sort of attractor-based variation where we have a regular grid which morphs to create a sort of what we call forced moire. We think about the forced moire much the way the deconstructivists talk about forced perspectives, and the way the forced perspective is used to kind of generate volumetric distortion. We use it here to generate sort of visual distortion. And it's set up geometrically as a series of radiuses that are attached to these diagrids. Those radiuses adapt towards their distance from a perimeter frame or an attractor curve, and create kind of shifting dimensions where we are basically creating a series of different colored frames. Each is an aluminum sheet which has been bent into position but is colored differently, so you get a kind of shifting arrangement, which you see here. So basically what you're seeing here is a zoomed in version where you see these things kind of reacting towards the attractor curve and changing shape as the attractor curve moves around, and we're able to use that attractor curve to kind of curate the views and highlight the moments that we're interested in. And so as you zoom out, you kind of get a sense of this kind of moire effect, and then as you move laterally, you start to see this kind of shift between the white cells versus the colored cells, and how we get this kind of gradient effect. That was then rationalized through many, many processes into exactly 5 panels. So what we have here is 5 pre-constructed, prefabricated panels that were made in the shop, brought to site, and then rotated and arranged on site to create a series of variations. As you saw, we started off with freeform variation, and because of costs, had to move towards a linear gradient. So it only gradiates in a linear sequence as opposed to freeform. These are some of the drawings that we sent to our fabricators to array these things. Here's a detail of the final construction. You can see here the kind of shifting gradient between white and red. And you can see here one of the joints where those panels are being put together. And you can see the kind of gradient effect of the patterning, not only in terms of color, but also in terms of shadow. And then how you get these kind of pulses of the color that streak across. I take no credit for either the building or the landscape design. And then we also have a series of phase change LEDs that wash the precast facade behind and change color through the night. The next chapter I'm going to talk about is about geometric logic, and it's really about something that's not new at all to architecture, but really is now being talked about in a much more explicit way, which is about a relationship that's not defined by dimensions, it's defined by relationships. So the way that geometry interrelates to one another, and the way that you set up these relationships and play them out to generate new forms and new geometries, and also how you rationalize these things and how you potentially mass customize them. This is a same client, so because of that project, they awarded us another contract. This one, a full building, and opened Christmas Eve a few months ago, or about a month ago. Luckily, I managed to get a couple pictures in before they put up all the Christmas stuff. This is the site, just about here, and this is what it looks like at night. So it's intense. If any of you have ever been to Bangkok, it's an intense city. It's super, super dense, over the top sensory experience. And this is our client's office right here, and that's where we are. So this is central world. Our clients are central. This is their world. It's a 600,000 square meter mall, about 6 million square feet, third largest mall in the world, and we are adding 12,000 square meters. So it's about, I like to think of it as the period on the paragraph. It's like a little punctuation mark, but it's basically got two major points of access from the existing mall and from their office tower, and a third one coming from that department store right there, which create the opportunity for these two sort of atriums. What we wanted to do was really think about those atriums not as we saw there, as two paths and something that kind of was dropped into the middle of them, but actually as a sort of resultant of shifting relationships between these masses. And so these masses are shifted in a sort of parametric model, which we were able to have dialogues with the client and kind of, because it was set up parametrically, actually real-time sit with them and calculate what's the return on investment in terms of that massing square footage and the amount of void space that we're creating. And we kind of settled on a form, general massing, and then began looking at how you access, connect to here, which is actually a really interesting condition in Bangkok, which is the BTS, which is the Bangkok Transit, which runs through the city, which is an above-ground rail system, which has an above-ground walkway underneath, so you kind of create a second ground floor condition, which is about 25 feet off the ground. So we have these sky bridges which come off the building and connect to that. We wanted to kind of create those pulses from the city and map them against this facade and kind of bring them into the skin and use them to carve the building and think of the building as a solid mass that has been carved to reveal this kind of tissue inside. But obviously when you look at the building, you don't look at the horizontal surfaces, you want to see some flesh. So we kind of turn those things down and give you these kind of edge conditions which we express. Again, those pulses we kind of pick up as a series of kind of streaks of light and these kind of dots of light, and so those get applied onto the facade as something that's, again, mapped against these edge conditions, and parametrically are controlling a series of radiuses where we're working with the fabricator and their tolerances and trying to fine-tune the model to understand what their construction tolerances are and what they can actually manufacture. Here's the completed project. Few things we're not so happy with, like this kind of canning in the surface here where it was supposed to be prefabricated and manufactured off-site. What we just discovered is because of time restrictions, they decided to just bend everything on site by eye. So you can see. We're also, a lot of the things that are issues here are issues about working remotely and being over here while construction's happening over there. I don't know where those holes came from. If you notice, they're a little bit bigger than the other ones. They show up again over here. Surprise, surprise. In any case, you can kind of see how those lines carry through into the interior. We have one side which is an enclosed mall area. The other side is open air. So what you actually see here is open air. We have a retractable cloth fabric roof system. That tissue I talked about before gets expressed as this timber cladding, which then pulls inside and becomes the soffits on the interior. We have, you can kind of see the sky bridge over there in the back. It's really difficult to photograph because of the fact that there's that BTS running right here, and you can't get very far away from it. You're always really close to it. But you can see at night how the lighting and the backlighting of those perforations really kind of dramatically changes the elements or the kind of atmosphere of the location. They named it the Groove. I don't know if they were trying to have their variation of the Grove, but they also have the phase-changing color lights. I think it's a little bit too much. But it does sort of do what we were hoping for, which kind of pick up on that intensity of that Bangkok street life. This project is actually in the wrong place. It was supposed to be in the performative patterning section, so I'm going to talk about it in terms of performative patterning. It was a competition entry for a building in Taiwan, Keelung Harbor Terminal Building. Keelung is a part of Taiwan that is a heavy manufacturing area and manufactures a lot of composite parts for yachts and cars. And since we're architects, we like to think about the nicest yachts and the most expensive cars as references. These two cars, the Wally and the Lamborghini, are both made from carbon fiber. Carbon fiber has a really interesting property in that it's made out of woven fibers of carbon, which happen to relate towards this, which is a very interesting contrast, which is a hen cage made of bamboo, which is also woven. But if you take the name Keelung, which is Jilung in Mandarin, it means hen cage. So we ran with that. We basically wanted to think about not the hen cage per se, but the geometry of that hen cage versus the geometry of this and the manufacturing of those other two things, to think about the building as something that is looking at a carbon fiber or a composite skin that gradiates from being a stressed skin to a grid shell. And so here we've got some initial diagrams about how we take the massing of the program, begin to extrude it. There's an office tower above, terminal harbor building below. Similar to the Chelsea project, we begin looking at these fluent trace curves and develop this skin, but we're really looking at, we're very interested in gradients, and we begin looking at not having any rooms, but a series of level changes that create these gradient programmatic changes. So instead of having programs that are separated by divisions, they're actually separated by space. So you get more of a gradient condition. And that gradient condition we begin also looking at. We're working with Bureau Happold in Los Angeles here. Some of you may remember Greg Otto from USC, who's the principal of Bureau Happold. And this is the structural analysis of our geometry from Bureau Happold off of what we were hoping to achieve, which was 3 concrete cores which support these slabs, and then a perimeter exoskeleton, which is actually not a skeleton, it's a skin structure that becomes a grid structure. So there is a gradient condition. And that gradient condition here gets expressed within the skin in terms of the loads, and then we map that to get this kind of gradient from a thin skin to a deep grid shell, which also starts to give us our double layered skin for sustainability purposes and environmental purposes, which we look at here, where we're kind of overlaying the kind of structural properties against a series of environmental properties, looking at how we look at wind analysis in Vasari and use that wind analysis to think about how we deepen some of these structural conditions and actually begin thinking of them as air intakes, so we can actually kind of maximize them as natural ventilation opportunities. And you can see here how the skin now starts to become something that gradiates from stressed skin down to deep grid shell and gains thickness in each of those examples. And here's a detailed view of that project, or of the skin and the changes within the skin. Here's the building sitting in the harbor. And needless to say, it's a competition we did not win. One of the interior views through the main terminal entry. This is another project which we just submitted. It's a competition in Fuzhou, China. We just found out today we made it to round 2. We are now one of the last 3. So fingers crossed. It's a site which right now is farmland, like nothing, which means next year it's going to be a city. Has a small island across from it. It's a cross-strait cultural center. So it is a cultural center that is dedicated towards a relationship between mainland China and Taiwan. It's in Fuzhou, which is directly across from China and Taiwan. And so this is the center of Fuzhou, and this is our site, which if you extend that vector all the way, more or less gets you to Taipei, which is directly across the water. And so this is our site here in pink, and this is pretty much the cultural city that they're planning to develop there. So we take that vector we just talked about, Fuzhou is also called the Banyan city. Banyan is a tree, which has these deep, amazing roots that spread out and create these kind of amazing volumetric conditions through their rooted conditions. And so, having developed a little bit of experience working in China, we know that the Chinese love metaphors. They love poetry. And so we pitched this as these two buildings we're proposing are the seeds that we're going to plant on this site, pointed in the axes towards Taiwan. Those two seeds will expand, they will grow, creating this sort of network. This network expands and starts to interact with itself and becomes this kind of vortex condition that rotates within them. And the buildings are the trees. The buildings are the trees that we take as this is the sort of massing of all of the volumes put together, divided into a cultural center and a commercial center. And we kind of begin pulling them apart and expanding them with a trunk that connects them vertically. And then shifting them. That shifting arrays them and points them not only towards Taiwan, which you see here in Taipei, but also towards Beijing, towards Southeast Asia, towards points of significant interest towards the Chinese culture, where many Chinese have either come from or gone to. So China is a place that has actually, as you know, spawned a large immigrant population throughout the world. And so this project, we really wanted to be about kind of reaching out and framing views towards all the places that people in China have come from and are going towards. And then we look at something else we're interested in, which is form finding and taking that as a volume and shrink wrapping it. Like if you think about what happens at the airport when you take your furniture and you get it shrink wrapped to collapse it all into place, we're looking at shrink wrapping a bunch of things together and creating this sort of shrink wrapped skin or fabric skin. And the joints of that skin have to be panelized. So we wanted to kind of keep this motif of the tree and have this kind of structural pattern, which we're looking at branching patterns generated through Grasshopper and mapping those against our mesh and using them to create an irregular pattern which has a reference towards the tree but is not literally a tree. And basically what you see at night is that it's basically a fabric roof condition with a cast-in-place structural concrete structure below, and then those seams will glow from the light coming from below. That root network becomes to define the landscaping of the park and the way the landscaping works. You actually access the buildings as they move up through these lower entrances, and each of those apertures is pointing towards those significant points of departure. And that kind of branching pattern shows up again not only on the roof but also in the facade. And here's how it sits against the waterfront. So we just found out today we're in third place, fingers crossed. We'll see how this one goes. I've won other competitions in China before. I'll be very honest with you, it does not mean anything because we've won and actually lost at the same time. Had a project that we won canceled right away, and we actually spent more money on it than we won in the prize money, so it was still a loss. Here's some of the interior spaces moving through those big atriums and seeing the fabric ceiling from above. We're looking at it as a double-layered fabric ceiling, so we've got one layer and then a sort of plenum space within that fabric ceiling, and how that motif shows up again on the volumes of those programs which are nested inside. This is another competition which was done in Daegu, South Korea. It's very much inspired by these sketches by, now that I'm in front of you guys, I can't remember. Yes. Architecture of the Oblique, right? Paulo Vitruvius. Yes. Anyways, Architecture of the Oblique, Claude Perrin, Architecture of the Oblique, and thinking about how you look at vertical circulation and navigating through space where all surfaces are usable, and how, in his case, the human relates towards architecture through gravity and moves around. We begin looking at that in a very different way, but basically the site is connected between a park and a residential area. We look at this kind of meandering path we want to draw through our site to connect that park and the residential area, identify two cores, pull those cores vertically, and then began looking at how we connect these. So this project is really about vertical circulation and how there's no distinction between rooms or space and circulation. Circulation is space. And going back towards what I was just talking about, we take that mesh and relax it into a form-found minimal surface. And we're looking at how that minimal surface can be reversed from a fabric structure into a concrete structure as a thin shell concrete. Again, working with Bureau Happel here in Los Angeles. You can see through the section how you're able to kind of navigate. The park passes through the building underneath, and the core extends upwards. But also at the same time, what we looked at was the building is not about the object being inserted onto the landscape. It's actually about the landscape being peeled up and multiplying to create a sort of vertical park that moves through and arrives at this roofscape, which you see here. So we took the liberty to kind of re-landscape the entire park and have this park kind of extend up into this roofscape at the top. Here you can see how the building sits on the site. The landscaping moves up, you move through underneath, and then you get this condition where the building starts to peel and multiply. And you can get a hint here where you're starting to look in through this fritted glass double glaze system, where we're using, again, the mapping of the solar conditions to look at how we frit the glass to create this kind of performative pattern, but also how we begin looking at the interior spaces as a series of kind of gradient conditions, which are articulated. In this case, the gradient is defined by furnishings. So what the typical library has objects inserted into it, we wanted to think of all of the furnishings as kind of built in. So as the slope changes, sometimes they're seating, sometimes they're benches, sometimes they're stairs. And then you arrive at the roofscape above and this kind of sculpted garden. And you have this double layered skin, which I just mentioned. The last chapter I'm going to talk about here is called Informed Form, and it's something that we've been working with for a while. And it's really about something that has been around for a long time, mostly explored by this guy, Fry Otto, or most famously explored by Fry Otto, and his work with soap film and minimal surfaces. And more recently, he's doing this all in physical properties and finding out how you can derive these minimal surface conditions which are optimum for force distribution and develop what is called a form-force equilibrium. Again, this is done by, these diagrams here are done by Benaz, who may or may not be here, graduate from here. And we began cataloging with Grasshopper how you can describe form-force relationships through mesh geometries and how you could recreate kind of a catalog of known minimal surface conditions. So these known minimal surface conditions, they have names, Costa, Riemann, etc., are known mathematical conditions and can all be generated by algorithm. But I'll be very frank, my office is not interested in the algorithms or the science or the computation. We're interested in the performance and the form and the manipulation of that. And so we're interested in how we can think about those things and use the computation for what we're interested in. And so for us, it's more intuitive to think about how we could take these polygonal surfaces and manipulate them intuitively and reverse engineer these known minimal surface conditions into polygons, relax them through Kangaroo or Grasshopper, which is basically looking at a kind of mesh network and minimizing the spring network into these fluid forms. One of the first times I really began applying this is with a number of you that are here. It's a project in Shanghai for MoCA Shanghai, and done with myself, Neil Leach, who's here, and also Wendy Falk, who's not, and a number of the students I see here in the crowd. Done very, very quickly for the AAC. It's a manually formed found. We went through a process of trying to model it, and we were so pressed on time, we ended up actually just pushing forward and buying a lot of soccer net, sticking up a bunch of poles and playing around with it until we got something we were happy with. It's on the roof of the Mocha Shanghai. All of this is looking at the kind of idea of shrink wrapping again, shrink wrapping a series of MDF boxes that were CNC milled and placing lights inside of them and having them backlit. But it's something that went on to explore when I went to the University of Calgary and did a workshop there, where I was invited to do this one-week workshop. Took that same process and began looking at it, how we could, I gave these tools to the students, began working with them, and we developed this geometry, which would become an installation, which we basically reverse the forces, and instead of thinking of them as tension forces, begin thinking of them, instead of as a tension structure, as a rigid structure, as a rigid grid shell made out of stiff pieces and laser cut out of acrylic. And so you can see here, this, again, very, very difficult to photograph because it was in a very small room, so you had no room to get back and take the photograph. But so this is the installation as it was there. And that led to an opportunity with a festival called Beakerhead in Canada. So we're working on this right now. It's a pavilion for this international festival in Beakerhead, and we took that same principle and applied it to the scale of a pavilion. You can see here the site, and we're basically saying let's bifurcate those two flows of traffic, initiate these three major views to the surrounding landmarks on the site. This is the kind of rough proposal we gave, which they signed off on. We managed to get Questlove to DJ for us for the event. But we wanted to expand that idea and try to move away from the regularity of this towards an irregularity that was informed by another level of investigation. And so that secondary level of investigation here began to look at principal stress lines. So we began using a plugin for Grasshopper called Karamba, and we took that mesh surface and that shell structure and began analyzing the principal stress lines, which is basically, if you think of this as a homogeneous shell, the directions and the way the forces flow within that surface. And those stress lines we then mapped back against that mesh and began using that mesh to reconstruct. We reconstruct the mesh using those principal stress lines as attractors and kind of get a gradient mesh, which in this case we're looking at more of a triangular version, and in this case more of a hexagonal version, where they begin nesting with each other and creating gradients which actually articulate the structural conditions, but also put more material where you need more material and less material where you need less material. But also for us, it's really about the kind of optical effect and how that creates a sense of movement in terms of the way you move around this thing and highlights very specific focal points. The last project I'm going to show today was one we just recently completed. It's actually going to be here in LA very, very shortly, or actually in Palm Springs next month for Modernism Week. No idea why they want this for Modernism Week, but I'll take it. It was a competition organized by Volvo and the Plan magazine to develop a pavilion to showcase this, which is the Volvo V60 hybrid electric plug-in. This car is Volvo's first electric car, and what we wanted to do, so the competition had no specifications about power, just something to showcase this that can be taken down and erected and follow the car to different locations for them to showcase the car. There was 150 entries. You can see some of them here. These are the shortlisted entries. As you can see from the shortlisted entries, all of them really think of the pavilion kind of as almost a small building. We wanted to think of the pavilion more as a backpack, like something that you brought with the car, took out of the car, took it, erected it, and did what these things do, which is provide energy to charge the car. So there's a little video here that Volvo put together.
In spring of 2013, Volvo Italia and the Plan magazine launched the Switch to Pure Volvo open architecture contest to showcase the new Volvo V60 plug-in diesel hybrid at undercover trade shows and open-air venues in Italy's public squares, attracting over 150
It's the view from my office.
around the world. entry is the Pure Tension Pavilion by Synthesis Design and Architecture. The entire pavilion assembles and demounts.
There's Yuming, who's sitting over there.
And fits in the trunk of the car.
The Switch to Pure Volvo competition organized by the plan and behalf of Volvo was interesting to us in terms of the kind of questions and challenges that it raised.
They required that the structure is something that was easily assemblable, easily dismountable, and could travel with the car, and was an iconic structure that could really showcase the car. We saw this as a perfect opportunity to apply some of the research we've been doing into dynamic mesh relaxation and thinking about how we can look at fabric structure in terms of thinking of something that's lightweight, portable, and easily collapsible. So the original idea of this was that the structure would wrap up and bundle into like a little package, like a laundry hamper, and just kind of pop over, which would have put us well out of budget. So we ended up moving towards a CNC bent aluminum frame, so it is slightly outside of the final shape it's going to take. It gets tensioned into position by the skin.
On my spare time, I like to go backpacking, camping. So a lot of the stretch fabric aspects of it was something that actually was very attractive to me because it's something I was so familiar with, the lightness and efficiency, and also the elegance that the combination of the simplicity and sophistication conveys.
We took that a step further and began thinking about it as a charging station for the car.
We wanted it to actually be part integrated into the whole structure. That it's not just a plug-in interface with the power, but it actually produces its own power.
So when we saw this design, obviously, there were a lot of things that we saw that fit together.
After the winning of the competition, we went through a process of rationalizing the geometry to make it more buildable. Worked very closely with the Structural Engineers Bureau Happels, which are based here in Los Angeles and Culver City. And then we started working with Fabric Images, who are based in Chicago.
The design idea behind it was the idea of pure tension. We weren't sure how we were going to do it, but we started. And we started figuring out what worked and what didn't.
Where we're at right now with the frame is that we have vertical connections. The next step is to drill out and countersink all the connections for sectional, so it'll be flush connections, so it'll be nothing protruding.
And eventually, between the seamstresses,
So as you can see, we do a lot of work through Skype.
we figured out how to do it.
Ascent Solar provides us with these, which are flexible photovoltaic panels. So unlike normal photovoltaic panels, which are extremely rigid and extremely heavy, these are extremely light and flexible.
Because of that constraint, we had to choose a lightweight, 70% open mesh. And what's interesting about mesh relaxation techniques is they use the natural qualities of the material to create a shape. What's interesting about this structure is it takes the natural qualities of the Volvo and lets them inform the formal qualities of the structure itself.
The entire pavilion, in terms of the skin, fits into a small box, whereas the perimeter frame, because it is a kind of slip fit tube, like a tent, demounts and will fit into the trunk of the boat.
There is a positive side in that it provides solar energy, but there's a negative side, right, in that it heats the car. And just cooling the car to a comfortable temperature requires a lot of energy. So anything that could reduce the solar heating of the car while also providing the electricity that the car wants is a win-win situation. And also to do it in such an efficient way and in such a beautiful way, that is, was something that our innovation team always looks for, and it was great that, even though we had not founded it ourselves, that we could support the innovation process that could enhance our products and hopefully enhance the world at large.
The interrelationship of our structure and the car is something that kind of drew attention to the car and also allowed you to experience the car in a new way. I think what's really surprised me in this journey of producing this pavilion and winning this competition has been just how forward-thinking Volvo has been pushing the limits of what our fabricators are able to do. And they've been very supportive of that and engaged with us in the entire design process in terms of producing something that we think is really an amazing concept that we hope can be applied towards future products and future opportunities.
So this is the pavilion as we submitted it for the competition. At this stage, it was a carbon fiber perimeter frame and had a visual array which was of flexible solar voltaics, which was just kind of done as an aesthetic thing, and we hadn't really figured out where to put them for the most optimum results. The geometry basically was thought of as something that sat on 3 points to mimic the 3 modes of the car, which are pure electric, hybrid, and power. We looked at these physical 3D prints, which are basically testing different patterns for how we could look at meshing it. The original proposal was that the entire thing would bend into position like with carbon fiber. The carbon fiber frame, we couldn't afford that. Everything does fit inside the trunk of the car, however. So what we had to do was rationalize that perimeter frame, because now we were CNC bending it, which you saw in the video. So CNC bending has a very particular process where you have to set the machine to a pure radius, and we have a free-form geometry. And so what the CNC manufacturers actually charge you on is the programming time. So if you have to do a free-form geometry, which they convert into 1,000 radiuses, they charge you for 1,000 radiuses. So we were hell-bent on turning our free-form geometry into 5 radiuses. So we managed to get 5 radiuses out of this. This is actually all done by Yuming over there, who is soon to be a graduate of the PP program here. And basically looking at how we can then move forward, went through physical models. This is the structural analysis done by Bureau Happold again, another one of our regular partners. This is part of Bureau Happold's structural analysis, and Bureau Happold was very, very firm on telling us that our form finding in Grasshopper was pretty, but it was not accurate at all. That they had to do the form finding with their $47,000 a seat license software. They did it, and we found out that we were about 2.7% off. But that 2.7%, I have to say, is the difference between me having a lawsuit and the structural engineer being confident and saying, I'll sign off on it. So I'm very happy to pay for that 2.7%. This is the patterning we were looking at the competition stage, which we then looked at. Once we won the competition, we started looking at it in terms of analyzing the solar incidence on that surface for 360 degrees of rotation at 8 hours a day for the year. Right? So for 365 days a year at 360 degrees of rotation, we're analyzing the solar incidence, mapping that self against each other and overlaying that. Because the pavilion's going to travel, we don't have, like with the building, you have a site. You know where the sun's going to be, you know what orientations the building's going to be in. This thing is going to travel. So it's always going to sit in a different position. Based off of that, it identified the areas of highest incidence, which created a gradient pattern. We use that gradient pattern to put a gradient distribution of cells. Those cells get mapped, then put out into 2D space, unrolled, and from there we go to fabrication from those strips. Those strips, as I said, get unrolled and arrayed into strips. Again, CNC milled on a cutter here. Then the photovoltaics get applied to it. The perimeter frame being CNC bent. Everything slip fits, like just a series of tubes. This was the first time we assembled it. It was me, myself, Jason, who was responsible for the fabrication, Ken, who was also responsible for the fabrication. None of us had ever built it before. They had built the pieces. I had done the design. It took us about 45 minutes to assemble the whole thing. So we were very pleased with that. This is the first test without the photovoltaics attached. Now we have the photovoltaics attached. The original design was that all of the wiring would run through the seams. As usual, we ran out of time. So We have a nice little network of twist caps sitting outside. And one of the interesting things about this is the fact that PV arrays are only as strong as the weakest link, right? So because this thing is moving at different times of the day, different cells are actually working. So what we did was use this, which is called a maximum power point transmission controller, which essentially is a real-time sensing device which understands what all of the PV cells are pulling in and disables the ones that are falling below a certain threshold. So this is actually what's happening to the pavilion throughout the day. And here we have the final pavilion. It is on a tour of Italy right now. Its next destination will be back here in Palm Springs for Modernism Week. From Modernism Week, it goes back to Italy for the design fair in Milan, and then we'll end at the Venice Biennale in this summer. It's the last slide here, and some of you may remember this slide. I always end with this slide every talk I ever give. And the first talk I ever gave was at a conference called Digital Architecture. And I ended with this because I wanted to make a point about the digital aspect of what we do. When I graduated here at USC in 1998, we were talking about CAD firms and firms. Like there's CAD offices and then there's offices. And people were talking about which one are you going to go to? Are you going to go work for a CAD office or an office? You can't say that anymore, right? Like there's no such thing as a CAD office or an office. And right now there's talk of digital architecture and blah, blah, blah. 20 years from now, you won't be able to say that anymore either. Right? Like it is happening and it's done. It's not something that is about the future. It is the future. And I think that that's something really, really important in terms of the way we think about this. Because forgot to explain it, but that car right there that you see in the picture was not called a car in this photograph. It was called the horseless carriage. Right? So flash forward now, nobody says horseless carriage. Nobody cares that there ever was a horse. Right? Anyways, that's it.
I think we're open for questions for 5 minutes. One or two questions. If there's raise your hand. But I see you.
Alvin, the last project, is that a one-off, or is there going to be a reiterative exercise where you look at it again?
We are talking with some people about reusing the technology for other purposes. I'm not at liberty to talk about it. I had to sign an NDI. But we are also, we are not looking at it as a product for Volvo. I'll put it that way. And it was never meant to be a mainstream consumer product, which there has been some discussions where people have misunderstood what it was for.
One more question?
I mean, I guess a lot of your projects are sort of like hand design. How did you see when you were starting the firm? You think to yourself like you're just going to do buildings, or you thought you were going to do everything else, or was it just that sort of?
I think one of the interesting lessons I learned, there is a article by, it was Work AC. Work AC had an interview, and they were giving advice to those starting their own firms. I read that right when I was starting up my firm. And their biggest piece of advice was never say no. Never say no, but find out a way to make their yes or your yes your yes. Like find a way to make it about what you are interested in. Right? So be creative about how you approach things. And I think one of the things that I think is happening with the way, I think some of the things Dean Ma was referencing in terms of the way I approach architecture is that it's about design at all scales and of all types, and I'm interested in all of it, you know. But I'm interested in it on my terms or our terms, then I do make it a point to always say, sorry about that. I do make it a point to always say our, because I do believe there's no such thing as sole authorship in design, and it's something that we as architects have to, you know, honor. Like that is always a team effort.
Great. Well, thank you. Alvin?